Today we get to look at motion under gravity, and motion under gravity is still straight line motion. It means that even as we are dealing with motion under gravity, we are still going to use the three equations of motion, or call them the equations of constant acceleration. The three that are very common. Of course, in our previous videos we derived 5, but there are 3 that are very commonly used. Now it is still going to be motion in a straight line. The only difference here is that our acceleration is acceleration due to gravity. Now, when dealing with motion under the influence of gravity, it is presumed, or we shall assume, that we are not experiencing any kind of air resistance. And so, because we are not experiencing any air resistance, that is, in our presumption, it would simply mean that the object is falling freely under the influence of gravity. Now, gravity varies from place to place depending on where you are on the earth. In some places, gravity is 10 meters per second. In others, it is 9.8. Now, for the purposes for this video, we shall take our value of gravity, or the acceleration due to gravity, to be 9.8 meters per second. Now, just like we had earlier derived our equations of motion, or our uniform acceleration formula, those very equations are going to be used here when we are dealing with motion under gravity, and definitely the value of A is going to become negative G. Now, where does this negative come from? We all know that because we are on the earth, we are attracted. There is a force that pulls us towards the earth, which we call the gravitational force. This gravitational force acts towards the center of the earth. Now, meaning when you are to jump from a plane in the air and you're coming downwards, as you're coming, your speed will be increasing because you're coming closer to the force of gravity. So you'll be coming downwards with a very high speed. But if you are to throw a stone into the air, it means you're throwing this stone away from the force of gravity. It means as you're throwing the stone upwards from the ground, as it moves up, it will be reducing its speed. It reduces its speed until it reaches a certain point where its speed will be 0, then it will come back down to the earth. What does that mean? It means that as you are throwing it up, the speed keeps reducing. It means that the stone is moving up against the force of gravity. The force of gravity in this case is acting in the opposite direction to the direction of the stone that you're throwing up. That is why as it is moving up, its speed keeps reducing, its velocity keeps reducing. So because its velocity keeps reducing, it means that when you are throwing a body and it is moving vertically upwards, away from the earth, it's going upwards, its acceleration due to gravity will be negative G. Why? Because as you're throwing it upwards, it is decelerating. Its speed is reducing. Its rate of change of velocity is reducing as it's going up. Yet when you throw something, drop it from up, then you drop it down, it will move very fast. When you're dealing with straight line motion under the influence of gravity, when the body is moving towards up, it's moving away from gravity, or it is working in opposition to the force of gravity that is pulling it down, and so its acceleration due to gravity will always be negative G, and as a result the equations of motion will be like this. And of course, if the body is moving vertically downwards towards this earth, towards the center of gravity, it would mean that the value of G will be positive, and so it means that these equations will remain the way they are, only that the place of acceleration is actually G, which is meaning acceleration due to gravity. So we are going to do some worked examples to illustrate how these work. So we have a question right here. A brick is thrown vertically downwards from the top of a building and it has an initial velocity of 1.5 meters per second. If the height of the building is that, find the velocity with which the brick hits the ground. As usual, we first summarize the question diagrammatically. A brick is thrown vertically downwards. So it's on top of a building, right? So we are having this being our building, and right on top here we are having a brick. It's thrown vertically downwards from the top of a building, and it has an initial velocity of that. So our initial velocity here is 1.5 meters per second. If the height of the building is that, so meaning that as it's moving down, the height of this building is 19/2/7. Find the velocity with which the brick hits the ground. Now, of course, as it's moving downwards, it's moving towards the earth, so it means that the acceleration is g. It's positive gravity. So it means the velocity with which it hits the ground definitely is going to be equal to v squared is going to be equal to u squared plus 2as. So the final velocity with which it hits the ground is what we are looking for. We shall call that v squared is going to be equal to u squared, which is 1.5 squared plus 2 times acceleration. We said in this video acceleration due to gravity will be 9.8, so it's going to be 9.8 times the displacement. Now the displacement, as it's moving from up down on top of the building, the height of the building is 19/2/7 meters, so it means that it's going to be 19/2/7 meters. So our answer will be 19.5 meters per second. That is the velocity with which it hits the ground. So part B, we are having they're asking us to find the time taken for the brick to fall. So to get the time taken for the brick to fall, using the first equation of motion, v is going to be equal to u plus at, and that's going to be our initial speed is going to be 1.5 plus our acceleration, which is the gravity, which is 9.8, times the time which we're looking for is going to be our final velocity. Of course, our final velocity we already got it as 19.5, so it's 19.5. When we make t the subject of the formula, we shall get our value of time as 1.84 seconds. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.